Hey everyone, and welcome. So what I wanted to do today was a real life ACT lesson with you all. So this is, of course, a virtual lesson. I'm not actually coming to your house right now and doing a lesson with you, but you understand the idea. We're gonna work through these ACT math triangle questions together. I'm going to show you the question, give you some time to respond, give you some time to think about it. Then I'm going to show you a host of different ways that I think we can solve this question so that maybe one way works well for some people, maybe one way works better for other people, but everybody can find a way that works well for them. Now, we're about to jump into it and look at our first question, but I just want to give a quick reminder because I know this is really important with math specifically. Some of these math questions are going to be hard and you might not know how to do them, and that's okay. A, we're going to work through them together, but B, if you feel a little anxious about not knowing how to answer a question, that's not a big deal. You can work through that. We've got a video here, and I'm gonna link it right up here about test anxiety specifically and 10 tips on how to get rid of it or how to deal with it. But just know that, if you're feeling a little anxious, you can leave a statement down or a comment down in the comments and say, hey, feeling a little anxious. And my guess is that a lot of people are going to be in the same boat as you. So anyway, just want everybody to know that before we get started. Not a big deal if math makes you a little anxious. Just keep rolling with it and know that there's other people in the same position as you. So let's get started. So I'm going to turn a little bit over to the side here, and we're going to look at our first question here, right? We have that Juanita walked from her home to the bakery, first walking 0.3 miles due east, and then walking 0.4 miles due north. What is the straight line distance in miles from the bakery to Juanita's home? So, good thing to do when we are doing a lot of ACT math questions, and it's to become good artists. Honestly, that's like an important skill set here. So I'm going to give you a second here. Pause the video, go ahead, work it, see what you can do, but know that my hint is draw stuff out, become a good artist. So pausing now. And hopefully you've now taken a quick little pause and taken a second to solve it. But I'm going to show you how I would solve this. And we'll see at the end. I'll give you the answer too. But first, you should see how I solve it so you know how that works. So let's just go ahead. Like I said, we want to become good artists here. And let's just go ahead and draw a location here that we can have as where Juanita is starting, right? So we're going to just put a tiny little dot right here. This is where Juanita started. We're going to make her start color purple. That's a good color for where she started. And then what did she do first? We know that first she moved east, right? So first thing we want to do is let's get a little arrow going here maybe. And we can draw a little arrow here and say, okay, this is her going east. And that wasn't quite straight. Let's see if we can get that straight. So we know here it's an arrow. She went east. East is this way. And let's make this a little bigger just so we can see it. Perfect. That looks pretty great. So we want to, oops, that's not what we wanted to do. Let's go ahead and get this right. So it's where she started. Again, if you're drawing this with pen and paper, you're probably going to, it's not going to be quite as colorful and stuff, but that's okay. So she went east here, and we can just go ahead and, I like to keep some notes as well. I think that's a really good thing to do here. So let's just get a nice font for ourselves that looks good. Probably bring it up to about 30. And let's just keep track of this. So she did 0.3 miles east. East. Let's see why. What is that? It wants me to capitalize it. Okay. Well, that's fine. Okay. So we have that. We're going east. A pro tip as well. I have students often mention that they struggle with north, south, east, west on these questions. If you do, it's good to just go ahead in here and I'll just, I'll just draw a little compass rose over here for myself. So I'll say, okay, I remember that north is always up, right? And north is always up. And then I know as well that east is always going to be over here to my right. And I'll just do that. And then sometimes I'll just even, go ahead and say north and east over here. Oh, that's not the right location for east. See, it's difficult for everyone, especially when you're drawing. Anyway, I'll draw a little compass rose. I don't need to do that for you right now. You guys can do that on your own. But just to keep track of north, south, east, and west. But for now, we're going east is this way, right? And we want to say, what did she do after this? Let's see. She went north. Okay, so we know from our compass rose a second ago that north is going to, in fact, be up. So let's just go ahead and see if we can make that work like that. That's up. And let's see, we actually went a little further. We went pretty far up. We went even a little bit further than we went east. So we went, how far here did we go? We went 0.4. Nope, 0.4. Let's see if I can type. Okay, good deal. So we did 0.4. That's looking pretty great. And now we've got a really good little diagram here of what we want. And let's put a point here because she didn't go any more directions. This is where she ended her her journey here. Let's just get this. If we can, hopefully, we'll just bring this up one so it looks a little better. Maybe not. I'm trying to get these to snap. That's okay. For now, though, we'll just make this another color. She got to her destination, so it's going to be green. That's a good option for us here. So now we've got this great diagram, which gets us most of the way, because what we can start to see here is that this is maybe looking a bit like a triangle, right? Because what we have here ultimately is we want to know how far it is from her start place to her end place here. And this, to me, it looks quite a bit like a triangle. So we can imagine here, if we want to kind of imagine where the triangle is, we see, okay, here's a leg, and there's the hypotenuse, right? And we can then imagine, okay. And so basically this ends up just being a triangle, right? We can click on it here and we're going to have a little bit of some weird stuff going on here with these arrows just changed, but ultimately this is a triangle, right? I don't know exactly why these arrows changed. That should be fine. Anyway, ultimately we want to know how far this distance was over here, right? What was this longer distance? And it's not 0.4 miles and it's not east, but we can think about if we see a 0.3 and we see a 0.4, it reminds me a lot of those tricky little 3, 4, 5 right triangles that we see. So I'm going to just go ahead when I see triangles and I see a 0.3 or a 3, I see a 0.4 or a 4, any multiples of a 3, 4, 5 triangle, I'm going to think, okay, this is likely 0.5 miles. Now, right off the bat, I would say, okay, according to that, the answer should be D. And it ends up being D. So if you said D, good work, you got it right. But if, you're not as comfortable with 3, 4, 5 triangles, you can also just go ahead and use your calculator. And you can take this number right here. We'll make this this number right here. This is one of our legs, and we'll make it purple. And we could take our other leg here, and we could use the Pythagorean theorem, right? A squared plus B squared equals C squared. And if you take 0.3 squared, add it to 0.4 squared, you're going to get 0.5 squared. It's the 3, 4, 5 triangle at work there. Again, if you're not familiar with Pythagorean theorem, check out our video that I'm linking right here on the top 10 formulas that you need to know for the ACT. But this is basically what I'm thinking we need to know here for this question. Like I said, our answer here ends up being D. So with that, I think it's time to move to our next question. As we move along here, the questions will get harder and harder. So don't be worried about that. That's just kind of how the ACT works, and that's how it's going to be here for us. So next one might be a tiny bit harder. Maybe it'll be a little easier for you. We'll see. If you want like printouts of these diagrams, I'm going to make nicer versions of these. They will be available in the ACT Everything course, which is going to be linked in the comments. So check that out if you need it. But for now, let's clear this out and let's go to our next question here. So given that angle R is the included angle between two congruent sides of the isosceles triangle RST, and the measure of R is 50 degrees, what is the measure of S? All right, so taking a second here, I'm going to pause and see if you can solve this. And we are back. So let's see about this. We've got an angle R, and it's the included angle between the two congruent sides of the isosceles triangle RST. So it's time to draw. We love doing some drawing here. Let's go ahead and start by drawing an isosceles triangle. So little vocab update here. If you don't know what an isosceles triangle is, it is a triangle with two equal sides and two equal angles. So I'm going to try and draw a bit of an exaggerated version of this right here for us. And we're going to draw another side here. And we're going to hopefully, let's see, let's change this up a little bit. We want actually to have some stroke to our line here so that we can see it. And we are going to do, there's one line, and let's just duplicate that. And we can just do this, and we'll move it here, and we'll move it here like this. We're going to get something that is going to be roughly an isosceles triangle. Actually, we can probably get it pretty exact here if we just know that this is like that. Okay, so we've got a beautiful isosceles triangle here for ourselves. Like I said, drawing is the name of the game when we are working on this. So we have that R is the included angle between the two congruent sides. So that means basically that R is going to be, I'm going to need to get my text tool here. R is going to be up here, and S can be down here. Oh, no, that's not what we wanted. S is down here, and T is going to be right here. So if R, again, we want to make sure we've got all of our diagrams in here. R is right here. That's 50 degrees. Now we want to know what the other two sides are. And we have a little bit of algebra to do here. I don't know what these are. And if I don't know what they are, that's okay. That's fine in math. Ooh, we don't want to do that. It's fine in math not to know what something is. In fact, that's often where we are. But if we don't know what it is, let's just call it X. We don't know what S is, and we don't know what T is either. So we don't know what T is. If we don't know what something else is, we can call it X as well. And in this case, we can call this X because we know S and T are equal, right? They're the same thing. So if they're the same thing, we can call them the same variable, the same X. If they weren't the same thing, if they weren't equal, we'd have to call one X and one Y, and it might make things a little more complicated. But since they are equal, we can just go ahead and call them the same thing. Now, helpful little formula here. The sum of the angles in the triangle are 180 degrees, right? If you sum up all three, they're always going to equal 180 degrees. So I can just do that algebra for myself really quickly here. We can type it out. We can say 180 degrees equals, okay, what do we have here? 50 degrees. plus x degrees plus x degrees. And we can simplify this down a little bit. Maybe we want to just copy this because I don't want to have to retype all that. We can simplify it out a little bit. And I'm going to just change these x's into 2x. If I have two numbers added together and they're two variables added together and they're the same variable, if they're added, we can just call them 2. And we can simplify this a little bit more here, right? We can subtract the 50 and we can just say this becomes 130 degrees. And we have 2x equals 130 degrees. And if we divide both sides by 2, 130 divided by 2 is 65. So x equals 65 degrees. So sure enough, we're looking at this and we're seeing, okay, angle S is 65 degrees. The answer must be C. And sure enough, it is. If you had a different way of solving this, go ahead, leave it in the comments. But remember, if you're struggling a little bit with formulas, go ahead and watch our video on my top 10 formulas. That should help you a bunch. But for now, I think this is about good on this question. We can go ahead and start moving to our next one. So we've got here, in our right triangle ABC shown below, sine of C equals 5/7, and the length of AB is 14 inches. What is the length of AC? So they've done a lot of our drawing for us here already, which is nice. Oftentimes the ACT makes our lives easy and they decide that they are going to be an artist for us and just go ahead and do the drawing for us. Now, when we are seeing sine, cosine, tangent, any of these, it's important to remember this little acronym that we like to use here. And it is called SOHCAHTOA. SOHCAHTOA. So basically what this is short for is that sine is opposite and hypotenuse. Cosine is adjacent and hypotenuse. And tangent is opposite and adjacent. This We're going to talk a little more as we move along how we're actually going to use this. But ultimately, right? Ultimately, this is kind of, for the sake of the ACT, the meaning of sine, cosine, and tangent for us. Sine is what we have here. Sine is equal to, and I should actually make this look a little bit better. Let's actually do the division signs here. Sine is equal, sine of some angle, theta, is equal to opposite over hypotenuse. So sine of our angle C here is equal to 5/7. If that's the case, right? If sine of whatever this is equal to 5/7, that means that our opposite side is kind of like 5. And I'm going to explain what I mean by kind of like 5 in just a second. And our hypotenuse is kind of like 7. So let's just go ahead first here and actually see if we can get these lines drawn here. Okay, let's see this. Let's make this a little bit bigger. Okay. This is our opposite side right here, right? It's opposite of our angle. So I'm going to make our opposite, let's make it purple for now or something like that. How's that? Purple looks great. And our hypotenuse, right? That's always the side that's across from our right angle. So it's going to be kind of like right here. Let's make our hypotenuse green. That's kind of a fun color for that. And what do we want to do? Let's just go ahead and we'll make, we're going to make our adjacent side here too. We're actually not going to really need it for this question, but I'm going to just put it in here so that we know that our adjacent side is going to be yellow. A great color for the adjacent side. So now we have this nice colorful triangle. I do like making things very colorful. I think it's kind of fun. So if our opposite side is kind of like 5, right? What we've said here, and we're going to actually set this up as a proportion, our opposite over our hypotenuse, we'll actually do it like this. This is, let's see if we can do this. That should work fine. And that's our hypotenuse. This is basically going to be equal to, and let me see if I can get an equal sign in here for us as well. Perfect. 5/7. Now, in this case, this triangle is a little bit bigger, right? It's a little bit bigger than what our 5/7. That's like a reduced fraction, basically. It's a little bigger than that. So when we have something that's a little bit bigger, we want to start using proportions. So let's think here. We don't know what this is, but we do know that our opposite is 14. Oh, 14. Good, 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 good. Nope. There we go. Let's escape. So that means that when we have proportions like this, we can do that awesome little cross multiply and divide thing here. So what I'm going to do is just go ahead and we'll make this, what color should we use for cross multiplying and dividing? Maybe we'll use, I don't know, what's a good color for that? Red? It seems compelling. Let's do red. Okay, red. So cross multiply, boom, like that. And this, let's give it this so we can actually see it. And let's do this so we can see cross multiply and divide. That didn't really look that good. You know, if you're struggling with these fractions, cross multiplying, dividing, manipulating fractions, I actually made a video all about fractions, so just watch that. But cross multiply would be 14 times 7. That's the multiply part, and then the divide part is the divide by 5. So if we just do some math real quick and say, what is 14 times 7? And then we want to know what is that divided by 5? We can just go ahead and check that out. And we know that it ends up being 19.6, which sure enough is our answer. 19.6 right there. Very cool. Very cool. And we would just choose J. We'd say number 30, we got it right. And this is awesome because we're getting along, we're about halfway through our ACT now in terms of question difficulty. These questions are going to be more difficult. So that's honestly, pat ourselves on the back. We're getting these harder questions right now. But with that, I think that's about all we need to worry about for this. Oops. So let's just go ahead here and move along to our next question. So we have two motorcycles that are starting at the same point at the same time. They travel away from each other at a 90-degree angle. And one travels at 40 miles per hour and the other at 60 miles per hour. And if they continue to travel at these constant rates, after about how many hours will they be 200 miles apart? That is our question here. All right, and we're back. So let's go ahead here and start drawing, right? We've got our two motorcycles and they're starting at the same point. So this is going to look a little bit like some of our questions. Actually, it's going to look kind of like that first question we did a little bit at first. We are going to just have a nice little point where these guys start right here. And let's go ahead and get this designed a little differently. Oops, okay, what's going on here? We want to make this thing purple because that's our starting point. Our starting color is always purple here at Granite. That is the rules of the road. Okay, perfect. There we go. We've got our starting point. And one of them, well, actually, it doesn't even bother to tell us which directions, but we know that they're moving at 90-degree angles from each other. So let's just go ahead and draw that out for ourselves. And we'll say, okay, here's one. Oh, let's get let's get a nice straight line here for ourselves. And there we go, that's 0 degrees. Let's go ahead and we're gonna make an arrow so we can see kind of how we're moving here. It's always good to keep arrows when we're doing any of this kind of stuff, whether it's physics class or anything like this. It can be ACT, physics class, you name it. It's great to have arrows so we know the directions that our things are moving. And again, let's just get this nice 90 degrees here. Let's see if we can get this. Okay, there we go, 90 degrees. Perfect. And one of them is moving at 40 miles per hour and the other is moving at 60 miles per hour. So let's make this longer one. This is going to be 60 miles per hour. And that looks pretty great. And let's do this other one. Ooh, okay. This other one, we're going to just call this 40 miles per hour. Okay, yikes. There we go. Okay, so we've got a basic diagram here that's very helpful for us. Now, if I'm moving 60 miles per hour, I have to think, how far have I moved in 1 hour? 60 miles per 1 hour would mean I've moved 60 miles, right? And if I'm moving 40 miles per hour, how far will I have moved in 1 hour? Again, thinking about it, we would have moved 40 miles. So here's the trick though. We want to know how long it will take them to be 200 miles apart from each other. So I like to sometimes just kind of get started and see roughly where I'm at. This is kind of an estimation game, and see, okay, if they had traveled 1 hour, we would know that it's basically this far, right? The line I just drew here. And I'm going to actually make this a color here. We're going to make this a little bit bigger. Hopefully we can see it. This is their distance away from each other. And what color do we want to make this? Let's make this, it's going to be kind of hard to see. Let's make it purple. That's a pretty decent color. Okay. So that purple line is how far they are from each other. And again, right, this is the name of the game, the usual kind of situation we have here. It's a right triangle, right? So after 1 hour, they're 60 miles from the point and 40 miles from the point, 90 degrees from each other. So that means they are 40 squared plus 60 squared. The square root of that, right? It's the Pythagorean theorem, again, that we are using here. So just going along with that, if we want to know how far they are from each other, we can do that with our rusty calculators right here. So I'm going to do it right now myself. You do the same, and we can just see what that comes out to. And let's see here if we just, oops, I'm hitting the wrong buttons. Okay, so we get about, if we just do all that out, about 72.1 miles. So we know that's not far enough yet. We want 200 miles. And we know that for every hour we go, we get a certain more amount of miles, right? If we went 2 hours, we'd go 80 miles and 120 miles. So however many hours we go dictates how much further out we go. So what I might want to do is set up a little equation that looks kind of like this. 40 miles per hour times X hours, that is going to equal just a certain amount of miles, basically. And if we do that, and we could square that, and then we set this other equation up here, and we say 60 miles per hour times X hours, that's going to give us how far we've gone in terms of time. For our other side, we do all that, that needs to equal 200 miles, and it's squared again, right? We're using Pythagorean theorem here. Again, if you're struggling with Pythagorean theorem, check out our formulas video, and that will help you. But if we do this, right, now we can just go ahead and solve this algebraically, and it becomes, not too bad. And we'll do this other math here. And we're going to say that's going to be about like that, x squared. And that is going to all be equal to 200 squared, just like that, which is going to be 40,000. And I'm going to actually put some commas in here just because I think that's going to make it a tiny bit easier for us to keep track of what all these numbers are. Now, ultimately, we can simplify things down a little bit, right? If, again, we've mentioned we have 1,600 and we have 3,600, those have the same x squared. So we can just add them together, and we're going to get 5,200. So that's going to be 5,200 x squared like that, and that's going to equal 40,000. And then we just got to do a little bit of division here and just say, okay, what is 40,000 divided by 5,200? We'll see if I can do this on the fly perfectly. It looks to be about 7.7. And last step here, we'll take the square root of both sides. What's the square root of 7.7? Well, we're going to find out. And that gives us about 2.8. 2.8 hours. Now we're going to go look at our answers here, and we're going to see what looks about right. And sure enough, it's B. And we have got that question right. Now this all looks pretty great. So let's go ahead here to our next, and actually it's going to be the last question of this segment. It's going to be number 43. This is our last triangles question of this test. Like I said, this is an official test. Let's solve this. There are a couple other questions on this that use triangles, but they would fall into our advanced category. And I'm going to do a video on those very soon. But let's see, if we have some angle theta between 90 degrees and 180 degrees, we know that the sine of that angle theta is 8/17. So what is the cosine of this angle? So remember, the name of the game here is SOHCAHTOA. We want to use that. And we're actually working with some degrees here in a way that having the unit circle drawn out is actually going to be really pretty helpful to us, or kind of at least something of that nature. So let's just go ahead and do that. We're going to draw this out, and we're going to do this like this, and select that. And let's go ahead and make these just a little bit more visible to ourselves. What do we want to do? Three should be great. Let's make them purple. Nope. That should be good. And slightly larger. Okay, there's our unit circle. And we know that we're somewhere between 90 and 180. Now, if you need help with the unit circle, I'm going to make a video on this specifically because it's actually, I remember being really hard for me when I was a student. It was very confusing to me at first. So nonetheless, we know this is a triangle that's going to be somewhere over here, basically. And again, what we can do here is we're going to actually change this color quickly. We're going to drop down, okay, something like this. And we're going to get another line going here from this point. Nope. Hopefully just like that. Oh no, that's an ellipse, not a line. We need a line here. There we go, perfect. There's that. And let's go ahead, and we're going to actually want to make this dotted. It's usually good to have this look a little bit dotted when we're doing these. Dashed line, that should be perfect. Okay, so here we go. We've got this nice unit circle set up. Again, sometimes teachers will actually draw this with the full ellipse here around. You can do that. Just so you know, that's kind of what they're doing when teachers are doing the unit circle here. Let's just put it, it would be kind of like that. I'm not going to bother with putting the unit circle here for now, though. I think it's going to be okay without it. But like I said, if you're confused about the unit circle, just check out that video. So now again, we've got this triangle here, and this is good. We know that this angle down here is theta. And we know as well a couple other great things. We know that because of SOHCAHTOA, the opposite side is going to be, nope, that's not what we wanted to do. Let's bring back the text. The opposite side here is going to be equal to 8, and the hypotenuse is going to be equal to, let's see if we can not do this. Let's see if we can bring that back too. That's not really what we wanted to have happen. Okay, that's fine. we'll do this. We're going to say 17, and we're going to bring it over here. 17 is going to hang out just like that. So sure enough, we have 8 here, we have 17, and if we want to know what the cosine of this angle is, we want to know basically what the adjacent side length is here, and I'm going to mark this as side that we want, and the adjacent over the hypotenuse. So to find that adjacent side, we can just use a little Pythagorean theorem, basically, or we can also just know that the 8, 15, 17 triangle is a common triangle that we like to use, or a common Pythagorean triple we like to use. So we could just say, okay, well, we know this is 15. So then if we're looking for our adjacent over our hypotenuse, that puts us in a position here where we are looking at 15 over 7. Now, there's something really important we need to pay attention to, and it has to do with this unit circle. Notice that I'm actually in the negative direction here. The unit circle is this kind of circle that's inscribed around our Cartesian system, and if we're moving in this direction here, we're in the negative direction. Up is positive, down is negative. To the right is positive, to the left is negative. So this can trip people up, and it actually wouldn't have thrown you off on this question because 15 over 17 wasn't even an option. But we know that the reason that D is our answer, that it's negative 15 over 17, is because of this unit circle going on here. And again, check out the unit circle video for more details on this. But that's our last question here. I hope that is helpful. Again, I'm trying to run this just like I would a normal ACT lesson. So it's a little bit less smooth than some of the videos that I put out, but I think that's good because I am hoping that you can see how I actually work through these. So I hope everybody liked this virtual lesson. If you are looking for all the formulas that I used here, and or maybe some print-offs of the actual problems I worked, those are all available, like I said, in the ACT Everything course. You can follow the link in the comments below, and you can check it out and see if that's something you might want to use as you prepare for the ACT. But also, this video, like I said in the intro, is all about triangles, right? Now, here at Granite, we break the ACT down into sections, right? There's obviously the math and the English section, but even within that, there's sections. So this was a triangle section, and there will be more sections to come, right? Sections on probability, sections on algebraic manipulation, all of these sort of things. If you're interested in these sections, you can also join the ACT Everything course, as I said, and it'll give you breakdowns at the end of a test once you submit it, how you did on each section, so you know the areas that you need to work on and the areas you don't. Maybe you're really great at probability and you don't need to worry about that. Maybe you're struggling with algebra and you need to work on that more, and it'll direct your studying in the course so that you can do only what you need to do, saving yourself time, making the whole thing more efficient. But like I said, that's all the formula and print off resources that you might want for this. And I am going to be releasing more videos, more real life lessons like this in the coming days and weeks for different sections of the math test. So we've got probability coming up, algebra coming up. So make sure to subscribe so that you can know when those come live and you can watch them. But I will see all of you then. Bye.